Okay. Let's see some more examples using the standard normal distribution. So one way that we tend to observe normal distributions are in assessments, so exam scores. So regardless of a raw exam score, if we have an approximately normal distribution, we can interpret each exam score and convert it into a z-score, which is, in terms of location relative to the mean, and measured in standard deviations away from the mean. So what is the probability that, as long as we assume that a randomly selected exam score comes from a standard normal distribution, what is the probability that a randomly selected exam score is between the mean minus 2.48 standard deviations and the mean plus 0.19 standard deviations? So what we're looking for is the probability that z is between negative 2.48 and 0.19. Now, in this case, we are actually looking at the standard normal distribution, so this bell curve, and we have two bounds, an upper bound and a lower bound. And this shaded region will give us the area of that shaded region will give us the probability that we're interested in. So one way of doing this, and as we've discussed when we're working with continuous random variables, is we can use the CDF function. So the CDF of the standard normal distribution, evaluated at the upper bound, minus the CDF evaluated at the lower bound. Which means we have two calculations ahead of us, right? So we can either use a table. So we'll evaluate this statement by finding in the table 0.19 and negative 2.48. So approximately what we find is this is going to be 0.5754 minus 0.0066, and that is 0.5688. Now, this is considerably more work than using a normal CDF function on a TI-84. So if you use normal CDF, remember that the syntax is lower bound, upper bound, so negative 2.48, 0.19, and then mean and standard deviation, which are 0 and 1 for our purposes. And this will give us the exact same value. Rounded, of course, the 4 places after the decimal. And so really there's just 3 really interesting cases that we're looking at when we're examining probabilities for a standard normal distribution. And as it's discussed in a theorem, we have 3 cases, right? So 1, if we're looking for the probability of an event that the standard normal distribution is less than or equal to a being some number, then our probability is just going to be the CDF evaluated at a. 2, if we're looking at z being greater than a, so an upper tail, then we'll use the rule of complementary events. So 1 minus the CDF evaluated at a. And 3, if we have an event where we're bounded between 2 values, just as we did in the previous example. Then this is going to be the CDF evaluated at the upper bound minus the CDF evaluated at the lower bound. So the CDF, again, is either you're going to use your standard normal area table, or you're going to use normal CDF. So regardless of which method you use, a table or a calculator, you are still doing that calculation and you'll get a decimal approximation for that area.